Hello and welcome to the second video in our series on stationary points, minimum and maximum points. And in this video we're going to have a little look at how we can use finding stationary points to help with our curve sketching. Now, the previous video we looked at locating the stationary points and using the second derivative to figure out if they're max or min. And in this video we're going to take that information and apply it to sketching curves. So here we go. We're going to have a look at two curves, two very different curves. This is the first one. Looks like a bit of a monster. This is, as you can see, this is a power 5 curve. So what we've got to do is figure out where all the stationary points are, and then we'll go from there. So first things first, let's do some differentiating. Here we go. There's the gradient function. dy dx is 7 plus 4x minus 18x. You know what, you can read that for yourself, that's fine. And so now what we've got to do is figure out where the stationary points. And I always like to include that statement, particularly if you did an exam, because we're telling the examiner we know exactly how to use gradients and the fact that it equals 0 to find our stationary points. It's always a good idea to include that statement in your exam answer. Stick it equal to 0. Now, that again looks like a bit of a shocker, but you know what? We've got the calculators, so we can just put that into the equation solver. So if you grab your calculators, grab the equation solver, you should know how to use that by now, and it will churn out like our answers. There we go. We've got two values. First one, minus 5 plus 2 root 15 over 5. And the second one, minus 5 minus 2 root 15 over 5. And then we've got another solution at x equals minus 1. So what that's telling us now is we've actually got 3 points on the curve where we've got stationary points. Next we've got to do is figure out what is going on with those stationary points. So there we go. There's the second derivative. And so what we're doing is taking our dy dx and differentiating it for a second time. There's our second derivative. And now we're going to take our values for x and put them into this statement here. Now, obviously, our first root is a bit of a shocker. So we're going to put that value in. You're far better off using the A and S key on your calculator rather than having to keep retyping in minus 5 minus 2 root 15 all over 5. So just by efficient use of a calculator, you can make that a whole lot simpler, and your calculator spits out the answer. Now it says 37.8. I've got to be honest, I don't really care how big the number is, what the precise number is. I'm just bothered about whether or not it is positive or negative. And in this case, it's clearly positive. And because it's positive, we said d squared y over dx squared is greater than 0. Therefore, it's a minimum. And there's another statement that you absolutely must include in your exam. Do not leave the exam to figure out just because you've got a value there that you know what it is. You have to actually clearly state it. Because it's greater than 0, therefore that means it's a minimum. So that's that one. When we stick in x equals minus 1, and that's a slightly easier one to put in, we end up with a value for d squared y over dx squared, in this case equals 0. And if you remember from the last video, what that tells us is that if it equals 0, we've got a point of inflection. And then for the final one, so it's the same as this one here, except instead of the minus, you can now see we've got a plus. And again, use your A and S key, figure it all out, plug it in, and you end up with minus 37.18 in this case. And again, the fact that it's the same value, just the native version, doesn't really matter a whole lot. What does matter is the fact that it's less than 0. Therefore, you've got a maximum point when x equals minus 5 plus 2 root 15 over 5. Right, so we've got a minimum point, we've got a point of inflection, we've got a maximum point. What we're going to do now is figure out what that's going to look like when we sketch it. So here we go. There's the information we had from the previous slide. So what we need to do now is figure out the coordinates of these points. So we've got the x values, so we're going to need the y values to go with it. So again, we're going to have to take this value here and put it into our equation for y. And again, make sure you use the A and S key, makes that a whole lot simpler. And we find that y equals minus 5.94 and a whole load of decimals. And when x equals minus 1, we've got y equals 0. And when we've got x equals minus 5 plus 2 root 15 over 5, we've got positive 5.94. Okay, so let's draw ourselves a set of axes and take this information that we've got at the top of the screen here and put that onto our diagram. So I know at that point there, I've got a minimum point, so I'm just going to kind of sketch approximately where that's going to go. So we've got a minimum there. The next point, we've got a point of inflection. So that means we've got it doing that. And then we've got a maximum point. There it is. And so those are our stationary points. What else do we know about the curve? Well, we also know the y-intercept. That's coming from there, so we know the y-intercept is at 11, so let's stick that on. And we know we've got a power 5 curve, which is essentially the same shape as the power 3 curve, but with extra bumps and humps in it. And because it's a negative power 5 curve, that means it's going to be starting up here somewhere, going down, back up, and then finish off, disappearing off the bottom of the screen down here. So with all that information, all we've got to do now is just kind of join all those points up. Here we go. And there's our curve. Cool. So there's our sketch, our power 5 curve with all our stationary points clearly indicated. And then when you're doing sketches, making sure you're very clear on where your turning points are, where intercepts are. The questions are always very specific about exactly what they want. They haven't asked for x-intercepts in this case, so we haven't got to worry about those. But we have got all our turning points in place. Right, so that was the first example. Let's move on and have a look at something that's looks a lot more simple on the face of it, but it's a very different type of curve to the one we've just looked at. So we've got this one here, y equals x plus 1 over x. So what's going on with this one? Well, first of all, let's get it written in a format where we can do the differentiating. So there we go, there it is, differentiated. Notice minus 1 comes to the front, so we've now got a minus sign here. And the stationary points are when dy dx equals 0. Notice I've kind of put it back into this kind of fractional form here, because I just think it's kind of sometimes easier to do when you're solving things. It's easier to deal with it in this form than this one, but it's entirely your choice what you want to do. And so we've got that, multiply the whole thing through by x squared, and we've got x is plus or minus 1. So we've got two stationary points. When x is 1, y equals 2. So we've gone back and taken 1 and put it into here to find the y coordinate. Put minus 1 into here. And we get minus 1, minus 2. So there's our two stationary points. And differentiate it a second time. Again, being careful with the signs. This has popped up because we've got a minus 2, bring the power to the front, it becomes positive. This thing here is easy to write as 2 over x cubed. And all we've got to do now is put our values of x into here to determine whether or not we've got maximum or mins. So let's put 1 into here. When x is 1, d squared. Now, clearly, in this case, when x is 1, this whole thing is positive. Yes, it's got a value of 2, but we don't actually have to state the numerical value as long as it's clear that we're saying, make the statement that it's greater than 0, therefore it's a minimum. And when x equals minus 1, we can clearly see that this thing here will be minus 1. So d squared y over dx squared will be negative, which means we've got a maximum point. Okay, so we've got, there's our equation of a curve, there's the information we've got about it. Now let's turn this into our sketch. Now with this one, because it's got this element here, which is the 1 over x part, we need to think a little bit carefully about that. It's always a good idea to think about what's happening around 0 and also what's happening as x disappears off to infinity. If we just look at the structure of this to begin with, though, this is basic. If I just kind of, that's my mouse gone, here it is. If we just ignore this bit for a second, we've got effectively y equals x plus whatever we're getting from here. Okay. So what that means is, if we consider as x tends to infinity, what's going to happen to that bit? We've got 1 over a massive number, which is going to be very, very small. So essentially 1 over x will tend to 0. So the curve comes very close to y equals x. Because this thing here is very, very small, but it's always going to be just a little bit bigger than y equals x. It's never actually going to touch y equals x, it's going to be slightly bigger than it as x becomes massive. And as x tends to negative infinity, exactly the same thing happens. So y equals x becomes an asymptote. And so when x is minus infinity, we've got y equals x take off a very, very small number. So y equals x is one asymptote. We've considered what happens as x tends to infinity. We've got very, very large values of x down this part of our graph, very, very small values of x down this part. And the other one to consider is what happens as x tends to 0. Well, as x tends to 0, what's going to happen to this bit again? Well, we're going to have 1 divided by a very, very small number, which means it's going to tend to infinity. And so if x is close to 0, that bit becomes irrelevant, and this bit is the only bit that's important because this bit is absolutely massive. But notice as well, we can't have x actually equal to 0, because if x was 0, this thing would be undefined. We don't get a value for y. So what that's saying is x equals 0 is an asymptote, and when we've got values of x very close to this line, that's tending to positive infinity on this side, and if x was just the negative side, it'd be tending to negative infinity. So what we've got is our minimum point, which is at 1, 2, it's looking like that. We've got our maximum point at -1, -2, which is there. And at x equals 0, you can see it's scooting off up to infinity here, negative infinity down here. It's getting closer and closer to y equals x, but never touching it from the negative side down here and from the positive side up here. So let's just finish off drawing the curve, and there we go. There's our curve. Now, let's say kind of that question might be a little bit beyond what you might have to do, but it's just a useful one just to see how we can think about curve sketching, particularly considering what's happening as we get close to asymptotes and what happens with minimum and maximum points. Jobs are good.